Alright, so today we're gonna be looking at why the square root of 2 is irrational, and this is a proof by contradiction. So initially we're going to assume that the square root of 2 is rational, and basically when we say that, we simply mean that it can be written as the ratio of two integers. And so it means we can write the square root of 2 as p over q, where p and q are both integers. And here's one very important assumption that we're gonna make, and that assumption is that p and q are both in their simplest form. Let's say that it turns out to be, say, 6 over 8. We basically just say that we already assume it's written as 3 over 4, not 6 over 8. So first off, we'll square both sides, so we'll end up getting 2 is equal to p over q square, p square over q square. So we get 2q square is equal to p square, and from here we can see that p square is even because it's being over on the left hand side we have a 2, and therefore it follows that p must also be even, so we can write that as p is equal to 2k. And now if we substitute that back in, we end up getting 2q square is equal to 2k whole square. And so we can say 2q square is equal to 4k square. And now we again end up getting q square is equal to 2k square. And so now again we can see that q square is also even because we have a 2 on the right hand side again. And so q is also even, which means it can be written as 2 times I, where I is just another integer, not the complex root. And so we can say that root 2 is p, which was 2k, divided by q, which we found out is 2i. But notice something here. Here both of these 2's are cancelling off. This means that it wasn't actually in its simplified state. And from this we can therefore derive that the square root of 2 is irrational, because it cannot be expressed as the ratio of two numbers without there being a contradiction.